Factoring the difference of two squares. There are some special situations that have special factoring methods. The difference of two perfect squares is one of them. Let's start. We are going to expand and simplify these binomials. Apply the distributive property. The middle two terms add to 0. So after simplifying, we get x squared minus 4. But 4 is 2 squared. X squared minus 2 squared is called the difference of two squares. We know the expansion of x plus 2 times x minus 2 is x squared minus 2 squared. Thus, the factorization of x squared minus 2 squared is x plus 2 times x minus 2. Another example. Let's expand these two binomials. The middle two terms add to 0. So after simplifying, we get x squared minus 9. But 9 is 3 squared. X squared minus 3 squared is the difference of two squares. We know the expansion of x plus 3 times x minus 3 is x squared minus 3 squared. Thus, the factorization of x squared minus 3 squared is x plus 3 times x minus 3. Therefore, whenever you have a binomial with each term being squared and the subtraction as the middle sign, you are guaranteed to have the case of difference of two squares. After verifying that you have a difference of two squares, you can now factorize it out as a product of two binomials, the sum and the difference of the two square roots. You need to know this formula by heart. Let's see how it works. Factorize the following quadratic expression. The first term of the binomial is a perfect square because the variable x is being erased to the second power. However, the second term of the binomial is not written as a square, but we know 25 is 5 squared. Clearly, we have a difference of two squares because the sign between the two squared terms is subtraction. The first term of the binomial is not written as a square, but we know 81 is 9 squared. The second term is a perfect square. Clearly, we have a difference of two squares because the sign between the two squared terms is subtraction. So we can factorize as we did above. In this case, we should remember that 1 is the same as 1 squared, so we have a difference of two squares. For the first term of the binomial, what is the square root of 4x squared? Or otherwise, which term, when multiplied by itself, gives 4x squared? That should be 2 times x. For the second term of the binomial, what is the square root of 36? Or otherwise, which term, when multiplied by itself, gives 36? That should be 6. The next example, you should try to solve by yourself and then check the full resolution. If you enjoyed the content of this video, don't forget to subscribe. And if you have any questions, feel free to ask or suggest anything. I will be grateful.